In this module, we're going to look at client-server design. So far in developing our sample application, we have created a logon procedure step where we have a user interface where we can enter a user ID and password and press OK. And then we're calling one action block that will validate the password, and then a second action block that has some database access in it to check if the user ID is valid. Because we've written our database access statements within this action block that's packaged or used within the window load module, that means the database access statements will execute on the workstation, so that we'll need to access the database using ODBC or SQLnet client, some form of remote database access. And whilst that's perfectly acceptable for certain classes of application, in general it's preferable to place the database access logic on a separate server which can be local to the database, will perform better and is more secure. So what we're going to take a look at now is moving this action block from executing on the client to executing on a separate server. So to create my server, I first need to create a new server procedure. So I'm going to create a procedure which I'm going to call Logon server, and I'm going to open the procedure step, and I'm going to define it as without display, and that's a prerequisite to creating a server procedure step, that it doesn't have a user interface. And then I'll open the action block for the server, and what I want the server to do is use my validate and log on action block that I've already developed. And the action block itself has an import view and a couple of export views. So obviously I need data views in the server to pass in the logon work import and receive the result and user details. So to do that, I'm going to do a view matching, and I'll just create an import view to match to the import view of the action block, and an export view of the result, and an export view of the user. So that's straightforward. And left as is, the logon server could only perform one function, which is the validate and logon. It's more usual for server procedure steps to perform multiple functions, and a simple way of instructing the server which function it's to perform is to use the special command system attribute. So when the command is, and I'll just create a new command of logon, then I'll just F7 move, I'll move the validate and logon action block. So when the command is logon, we perform that function. And then it's good practice to trap any invalid commands. So I'll just set the error handling if the command is not valid. So there's a simple server procedure step developed, and then in our logon, instead of directly invoking the validate and logon action block locally, I'm going to use my logon server and use the same view matching that I had for the action block, and then I can delete the action block. And the one final thing to remember is to set the command. So set the command to logon and invoke the server, and then the rest of the logic will remain the same. So there's the changes made to the client. We can still use our window packaging to test this. So what I need to do is generate that up. So far I've just created my new logon server. I need to add that into my window load module. So there's the two procedure steps in the load module, and I'll include the Logon server, and then I can generate the Logon server and build it. So that's done. And then I can test that. You don't have to separate the client and server. For window load modules, the client and the server can be in the same load module, so it makes testing easier. So then I'm going to run my test. Now, in the previous module, we didn't see this logon information dialog, and that's because I had predefined the user ID and password for the database access, and I thought I'd just take that out to show you what happens if you don't have the user ID and password defined. You have to enter them, and then the application executes as before. And that user ID and password is actually stored inside a file called ifgdic.ini, and if you edit that file and put in your password, then next time you execute the application, if we just execute that again, and this time it doesn't ask for my database user, it just takes it out of that file. So for local testing where the password doesn't need to be secure, you can put the password into the ifgdic.ini file, or if you don't want to do that for security reasons, then you would have to enter the Oracle password or ODBC password every time you executed the application. So that's tested the window load module, and what we can do now is move on and look at client-server generation. So I'm just going to close some of these editors, and for client-server, the first thing we need to do is the packaging. So far for window packaging, we created our window load module, and into that we packaged our menu and logon clients and our logon server. For cooperative client-server packaging, we separate them into cooperative client packaging and cooperative server packaging. So I'm going to start by creating the client load module, which I'll call my app C for client, containing the logon and menu, and I'll put in a clear screen transaction code so that we can start off the menu. So that's the client. And then for the server, I'll create my app server containing my logon server, and give it a tran code. And that's the server packaged. So we have our client load module and our server load module. So at this stage I'll just save the model. So now we want to generate those. So to generate them, we have client generation editor and a server generation editor. So we can generate our client code and we can generate our server code. So for our client code, because we want to still generate the client for Windows, but we probably want to keep our client C code separate from our window packaged code because it's going to be different. And one of the features of CAGen is that it generates the code into the model folder with the subdirectory of the language. So by default, when I generate my client code, it's going to overwrite my window packaging code because they're both generated for C. One of the features of Studio Developer is you can specify an alternate source path. So in this case, I'm going to generate my client code into a subdirectory of the model called CLT. So if I now generate and build my client code, and you can see if I go to the CLT directory, there's the client code that was just generated. And similarly for the server code, I'm going to generate my code, if I look at the options, into a server directory. One other point to mention is the build profile. In the build tool you can specify various profiles, so I've created an Oracle 12 build profile, and in the build tool that allows you to specify for the database properties like the database user, password, the location of the database library, various flags if you need to change them. So this is, you save this lot as a build profile. In this case I've called the build profile Aura 12, and within Studio Developer, if you're not launching the build tool but you're running the build tool in the background, you can specify which build profile to use using this field here. So I'm going to use my Aura 12 build profile when building my server code. So that's my server generated. So for the client, we can directly execute that using this test button. But when we execute it, the client is going to need to connect to the server, and the way that it does that, if we look at the client C directory, I've set it up so that it's using a configuration file called comcfg.ini, and this specifies how to connect to the server. So it's saying the star is any tran code, it connects using the TCP/IP protocol to a server called localhost, in other words on my machine, and on a port 3008. So it's going to try and connect to a server on that IP address on that port. So for example, if we were running this application with a mainframe CICS server, then we would put in the IP address to connect to CICS and the port that the CICS listener is listening on. In this case, we're going to run it locally. And the local, to do that, we're going to use something called a transaction enabler, which is a cut down TP monitor supplied with CAGen as an option, which it can be used instead of TP monitors like CICS or IMS, but specifically for the Unix or Windows platforms. So we need to start the transaction enabler, and I've just created a very simple batch file here which starts the transaction enabler daemon and funnel, and then I've set up environments for my port, in this case 3008, and a few other environment variables like my Oracle path and my CAGen path that are needed for executing the transaction enabler. So that I can start my transaction enabler, which starts the daemon and funnel, and then I can execute my logon, and there it's executed my server and checked that the user ID is valid in the database. So that's showing you the principles of client-server design, where we separated our application into code that runs on the client and code that runs on the server. Bearing in mind, for local testing we could still use window generation, where the client and server are packaged into one load module, and then when we're ready for client-server testing we can separately generate the client and the server and test those.